Hello everyone, welcome back to the challenge question walkthrough for Edexcel's Pure Year 1 textbook, and this time we're looking at chapter 10. Okay, and our first question is from exercise 10a, and part A asks us to prove that sine of 180 minus theta is equal to sine theta. Part B says prove that cos of minus theta is equal to cos theta, and part C says prove that tan of 180 minus theta is equal to minus tan theta. Okay. So there are many ways we could go about these questions, but I think the easiest here is to use the unit circle, which we are introduced to in this chapter. So for part A, so we can recall that if we have a line here, and this angle is theta, then the x and y coordinates of this point will be cos theta and sine theta. And if we look at where 180 minus theta would be on this unit circle, it would be here, where this angle is also theta, so that this angle here, this whole angle here, is equal to 180 minus theta. And the same as before, we can say that this point has coordinates cos of 180 minus theta, sine of 180 minus theta. And now what we can spot is that because of the symmetry of the unit circle, these y coordinates here are equal. And so we can say that sine of theta is equal to sine of 180 minus theta, as required. Now for part B, prove that cos of minus theta is equal to cos of theta. So again, if we look at the line here with angle theta, this will have coordinates cos theta, sine theta again. And this time we're looking at minus theta, which would be underneath the x-axis here, where this angle is also theta. And so we can say this point has coordinates cos of minus theta and sine of minus theta. Okay, now what we can spot this time is that because of the symmetry of the unit circle again, the x coordinates of these 2 points will be equal. So we can say that cos theta is equal to cos of minus theta, as required. And finally, for part C, we're asked to prove that tan of 180 minus theta is equal to minus tan theta. If we draw a line like we did for the others, with angle theta here to the horizontal, and if we remember, tan theta is equal to sine theta over cos theta, and this length here is sine theta, the y-coordinate, and this length here is cos theta, the x-coordinate of the point, then we can see that tan theta is equal to the gradient of this line, the rise over the run. And if we look at 180 minus theta, so that will be here, where this angle is also theta. If we think about the gradient of this line too, then we have that this length here is also sine theta, and this length is also cos theta, but because the line is going downwards this time, we have a gradient of minus tan theta. And so we have tan of 180 minus theta, so the gradient of this line here is equal to minus tan theta, as required. Our next question comes from exercise 10b. The diagram shows an isosceles right-angled triangle ABC. AE equals DE equals 1 unit, and angle ACD is equal to 30 degrees. Part A says calculate the exact lengths of CE, DC, BC, and DB. So if we're looking at CE first, if we draw out the triangle CDE, so D here, E here, and C here, we have 30 degrees here and a side length of 1. To calculate the length of CE, we're going to use tan. So we have tan of 30 degrees is equal to opposite, so that's DE, over the adjacent, which is CE. And so we have CE is equal to 1 over tan 30, and tan 30 is root 3 over 3. So we have 3 over root 3, or just root 3. Okay, and for part 2, we need to find the exact length of DC. And to do this, we can use Pythagoras, because we've got a right angled triangle. So DC is equal to the square root of DE squared plus EC squared, which is just 3. So that is equal to 2. Okay, and now for BC. Now we're asked to find the exact length of BC. And to do this, we can look at the entire triangle ABC. So drawing that out, we have B at the top here, A here, and C here. And this angle here is 45 degrees, and this angle here is a right angle. So this is an isosceles triangle with these two side lengths equal. And we know the length AE and the length CE from part 1. So we have this length AC is equal to AE, which is 1, plus EC, which is root 3. And we also find the length of BC. And if we call this length x, then we know that the length AB will also be x. And using Pythagoras, we have x squared plus x squared is equal to 1 plus root 3, or squared. And so 2x squared is equal to 1 plus 2 root 3 plus 3. So we have that x squared is equal to, so 4 plus 2 root 3 divided by 2, which gives us 2 plus root 3. And so x is equal to the square root of 2 plus root 3. And therefore we have BC is equal to the square root of 2 plus root 3. And finally, for part 4, we're asked to find the length of DB. So to find this length, we can do the length AB minus length AD. So the whole length here, take away the length of AD. And we know that the length AB is equal to BC, which is the square root of 2 plus root 3. Now to find the length AD, we can use Pythagoras on the triangle ADE. So this is the square root of 1 squared plus 1 squared, which is root 2. And so dB is equal to the square root of 2 plus root 3 minus the square root of 2. And now for part B, we're asked to state the size of the angle BCD. Looking at the whole triangle ABC, we have the angle 45 degrees here, 30 degrees here, and 90 degrees here. And so we have that the angle BCD is equal to 180 minus 90 minus 45 minus 30, which is equal to 15 degrees. And finally for part C, hence find the exact values for sine of 15 degrees and cos of 15 degrees. So looking at the triangle DBC, we have a 15 degree angle here and a right angle at B. And from part A, we can label these lengths. So BC is the square root of 2 plus root 3. And BD is equal to the square root of 2 plus root 3 minus root 2. And also we know that CD is equal to 2. And so for part 1, we have sine of 15 degrees is equal to the opposite over the hypotenuse. So the square root of 2 plus root 3 minus root 2 over the hypotenuse, which is 2. And for part 2, cos of 15 degrees is equal to the adjacent over the hypotenuse. So the square root of 2 plus root 3 over 2. And that is our final answer. Okay, and for our next question from exercise 10e, we're asked to solve the equation sine of 3x minus 45 degrees equals a half from the interval 0 is less than or equal to x is less than or equal to 180 degrees. So first of all, we can let u equal 3x minus 45 just for our convenience. So we have that sine of u is equal to a half. And looking at a graph of sine of x, starting from the origin, like so. Okay, we can see that we have solutions here, 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 and here. And if we look at the possible values of x given by this inequality here, we can manipulate this to give us the bounds for u. And we can do that by multiplying each of the terms by 3. So we have 0 is less than or equal to 3x is less than or equal to 540, and taking away 45 from each of these terms. So we have minus 45 is less than or equal to 3x minus 45 is less than or equal to 495. And then we can replace this by u. So we have minus 45 is less than or equal to u is less than or equal to 495. And we can see from this diagram here it's 180 degrees, here's 360 degrees, and here is 540 degrees. And if we continue the graph on a little further, we can see that this point here is minus 180 degrees. And so if we look at the solutions we have here, we'll have u is equal to 30 degrees. Here u is equal to 150 degrees. Here we have u equals 360 plus 30 because sine is periodic. So this solution here will be 360 plus this solution here. So that's 390 degrees. And here is the same. So we have u equals 150 plus 360, which is 510 degrees. And that is outside of our range, which is at 495 degrees. And here we're also at minus 45 degrees. And so we can see that our only solutions are u equals 30 degrees, u equals 150 degrees, and u equals 390 degrees. And now we can't leave our answers in terms of u because we're asked to solve the equation in terms of x. And so converting these back into x solutions. So here we have 3x minus 45 is equal to 30. So we have that x is equal to 25 degrees. Here we have 3x minus 45 is equal to 150. So we have that x is equal to 65 degrees. And finally here, 3x minus 45 is equal to 390. And so we have that x is equal to 145 degrees. And these are our final answers. And our first question from exercise 10F, solve the equation cos squared 3 theta minus cos 3 theta is equal to 2 in the interval minus 180 is less than or equal to theta is less than or equal to 180. So once again, we can let u equal 3 theta. So we have cos squared u minus cos u minus 2 is equal to 0. And this is a quadratic that we can factorize quite easily. So we have cos u minus 2 and cos u plus 1 is equal to 0. So we have that cos u is equal to 2 or cos u is equal to minus 1. And because cos only ranges between minus 1 and 1, we can safely cross off this solution here. So we get all our solutions from cos u is equal to minus 1. And once again, we are given our interval in terms of theta, but we need it in terms of u. So u is equal to 3 theta. So if we multiply all these terms by 3, we have minus 540 is less than or equal to 3 theta is less than or equal to 540. And so we have minus 540 is less than or equal to u is less than or equal to 540 degrees. And if we draw out the graph of cos of x from minus 540 to 540, so we're starting from 1 up here, going up and down, and the same on the other side. Okay, and if we label these intersections with the axes, here will be 90 degrees, here 270 degrees, and here 450 degrees, and here we'll have 630 degrees. And doing the same on the other side, we'll have minus 90 degrees, minus 270 degrees, minus 450 degrees, and going a little bit further, here we'll have minus 630 degrees. And now we're looking where cos u is equal to minus 1, and that is all of these points at the bottom of these curves. So here, 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 and here. This point here is going to be equal to minus 180. This one here is equal to 180. This one here, the x-coordinate will be 540, and here minus 540. You can see that we have four solutions which are all in range. So u equals minus 540, u equals minus 180, u equals 180, and u equals 540. Now, as we did with the previous question, we have to convert this back into theta. And so we have theta is equal to a third u. So dividing all these by 3, we have theta is equal to minus 180 degrees, theta equals minus 60 degrees, theta equals 60 degrees, and theta equals 180 degrees. And those are our four solutions. And the second question says solve the equation tan squared theta minus 45 degrees equals 1 in the interval 0 is less than or equal to theta is less than or equal to 360 degrees. So once again, letting u equal theta minus 45 degrees, we get tan squared u is equal to 1, and square rooting both sides, we have tan u is equal to plus or minus 1. Now looking at the interval again, if we take 45 from each of these terms, we have minus 45 is less than or equal to theta minus 45, which is u, is less than or equal to 360 minus 45, which is 315. And so, drawing the graph of tan theta between minus 45 degrees and 315 degrees, remembering that our asymptotes are at minus 90, positive 90, and also one at 270. So here, minus 90, 90, and 270. And our graph will look something like this. And so if we're looking at where tan u is equal to plus or minus 1, so here is 1 and here is minus 1, we can see that our solutions are here, here, and here, here, and here. And so from our key trig values, we know that tan of 45 degrees is equal to 1. So we have here, this point is at 45 degrees, and here is, because tan has a period of 180, 45 plus 180 gives us 225 degrees. And here, this will be minus 45 degrees. So this point here has x coordinates minus 45 plus 180 degrees, which is 135 degrees. And this point here has x coordinate 180 plus 135 degrees, which is 315 degrees. And all of these solutions are just in range. So we have that u is equal to either minus 45 degrees, 45 degrees, 135 degrees, 225 degrees, or 315 degrees. And remembering we need to answer in terms of theta. From here we have that theta is equal to u plus 45 degrees. And so adding 45 to each of these solutions, we have theta is equal to 0 degrees, 90 degrees, 180 degrees, 270 degrees, or 360 degrees. And that is our final answer. And now our last question for mixed exercise 10. Solve the equation tan to the power 4 x minus 3 tan squared x plus 2 is equal to 0. In the interval 0 is less than or equal to x is less than or equal to 360 degrees. So we can see that this is a hidden quadratic in terms of tan squared x. So if we let u equal tan squared x, we have u squared minus 3u plus 2 is equal to 0. And factorising this quadratic, we have u minus 1, u minus 2 is equal to 0. So we have that u is equal to 1 or u is equal to 2. And therefore tan squared of x is equal to 1 or tan squared of x is equal to 2. And that gives us four possible values of tan of x. which are plus or minus 1 or plus or minus root 2. And looking from the interval 0 is less than or equal to x is less than or equal to 360 degrees. If we draw out the graph of tan of x and our asymptotes at x equals 90 and x equals 270, our graph will look something like this. With 360 being here. And so looking at plus or minus 1, which I'll do in green, here, so minus 1 and 1, and then in blue, tan of x is equal to plus or minus root 2. So up here is root 2, and down here, minus root 2. We can see that we have 8 different solutions in total. One here, one here, one here, one here, one here, one here, and one here, and one here. All between 0 and 360 degrees. So these points here will be 45 degrees and 225 degrees. This one here will be 135 degrees. And this point here, 315 degrees. I'm using your calculator to find the inverse tan of root 2 and minus root 2. For this solution here, we get 54.7 to 1 decimal place. And down here, the inverse tan of minus root 2 gives us minus 54.73, and adding 180 to this, we get 125.3 to 1 decimal place. And adding 180 to both, we get these solutions here and here. So adding 180 to 54.7 gives us 234.7 degrees to 1 decimal place again. And down here we get 305.3 degrees to 1 decimal place. And so our possible values of, and so our solutions for x are 45 degrees, 54.7 degrees, and then we've got 125.3 degrees, 135 degrees, then we've got 225 degrees, 234.7 degrees, 305.3 degrees, and finally 315 degrees. And those are our 8 solutions. And that is the end of the challenge question walkthrough for chapter 10. I hope you enjoyed, and I'll see you in the next video.